July, Andalusia, 40 degrees centigrade in the shade. Weeks-long test campaigns in hot country testing not only demand everything from the equipment, also the test drivers and measurement technicians reach their limits under these conditions. This is just one of many scenarios in which most people would like their data logger colleague to take their place in the vehicle instead of having to work for hours in the vehicle with a laptop on their lap under these conditions. In our latest episode of CSM Explained, we take a look at how this gets possible and the functions that modern data logger solutions should offer to achieve this goal. We will therefore get to know various application scenarios. We will look at the strengths and the weaknesses of measurement computers on the one hand and data loggers on the other. And we will get to know some exciting features that will allow us to replace the measurement computer with an intelligent data logger solution in many cases, so that you can then say with a clear, concise, bye-bye measurement computer. Let me introduce myself briefly. My name is Timo Eich. I am Business Development Manager at CSM. And for the next 20 minutes, I'll be your personal tour guide on our short trip into the world of road testing. Data logger supported road tests are nothing new and are already standard in many areas. However, there are just as many areas of application in which supervised measurement computers are still used in road tests today. Let's take a look at a few application scenarios in the overview, namely data recording scenarios in road tests. On the one hand, we have the investigation of vehicle prototypes. In addition to pure data recording, prototypes often require constant adjustments to the ECU settings during test drives. Our test equipment should therefore not only measure, but also be able to calibrate and flash the vehicle's ECUs at the same time. In the pre-series stage, we tend to have to deal with repeated, more or less major adjustments to the measurement tasks, whereby the focus is here already clearly on measurement data acquisition. And in the pre-series endurance run, we are primarily concerned with measuring entail fleets and basically just collecting measurement data from as many test vehicles as possible. Typically, the fields of application in the area of prototype testing are a domain of measurement computer-supported data acquisition, because we simply have the tools available here to calibrate and flash ECUs, for example, products from our partner Vector Informatic. The endurance run, on the other hand, is a classic domain of the data logger supported road test, in which we want to measure autonomously and without operating personnel for as long as a period as possible. Well, where it's getting interesting now is the area of pre-series here. Until now, this field has also been the domain of the measurement computer. And perhaps a brief definition here of the term. What do we mean by measurement computer? By a measurement computer, we mean a laptop, either on the operator's lap, or if driver and the person in charge of the measurement technology are one and the same person, usually on a special holder in the passenger area. Laptops are also available in very robust versions, which are in fact oftentimes used in practice. So in the following, we want to compare the measurement computer here with a compact data logger, using the example of CSM's Unican free data logger, and check whether a data logger is also capable of taking over applications from the field of pre-series. There are very real reasons for this comparison, as some of our customers have approached us with the specific question of how they can replace their measurement computer with a compact data logger in certain scenarios. and without having to sacrifice important functions of the measurement computer. So let's take a look at one of these scenarios, and as you can easily see, not in Andalusia now, but somewhere cold, for example, at a development site in Austria in winter. And our customer's testing procedure looks then like this. The first step is to equip the test vehicle with the measurement technology. Then a test drive is carried out on the test site, and the vehicle then returns to the starting point. The measurement data is then viewed and evaluated as quickly as possible. And in the fourth step, the new insights are immediately put into practice, which often also involves adapting the measurement task. And this process now repeats itself over again, and again. Hence the title, Always in Loops. And we will go now through these 4 steps here together and compare the measurement computer with our compact data logger at each step. So the first step is to equip the test vehicle. And when using a measurement computer, a few problems immediately arise here. Firstly, when installing the measurement computer in the vehicle, the computer simply has a certain size and its typical shape, and neither size nor shape are ideal for installation in the vehicle. The laptop holders available on the market take up a lot of space in the vehicle, for example, large parts of the passenger area in the front of the vehicle. And that is precisely the problem if the test vehicle is driven very dynamically or even has an accident, because then the laptop quickly becomes a huge projectile in the vehicle. Another shortcoming in the laptop is the laptop's connectors for connecting the measurement technology, such as the Ethernet or USB interface. These are office connectors without a tight lock, which means that the vibrations that naturally always occur in the vehicle can quickly lead to connection interruptions due to the connectors that do not make reliable contact, or even connectors that shake loose, and unfortunately, this can also lead to severe data loss. And the laptops themselves also suffer from the constant shocks and vibrations, the ruggedized versions, of course, less than the pure office laptops, but they also suffer over time. And above all, the operating temperature ranges of laptops are often not up to the tough demands of hot or cold country testing. Well, most compact data loggers perform significantly better in all the points just mentioned. With its small dimensions, a compact data logger can be easily stowed behind covers or in the glove compartment, for example, and can also be installed when fitting other measurement technology. Our Unican 3, for example, provides only sealed and locking plug connectors that make reliable contact even under road test conditions, and also has no moving parts, and it offers an operating temperature range of -40 up to 85 degrees centigrade. Well, let's go straight to step 2, the test execution. How does the measurement computer cope this time? There are now 2 scenarios here. Either the computer is operated by the driver, or there is an additional person on board who takes care of the computer. And a second person is often essential, especially when operating the measurement technology is complex. However, this means that 2 people have to be in the vehicle at all times, whatever the weather. Just think of Andalusia when the temperatures are at the prime of summer, or cold country testing. Even with air conditioning, these are extreme physical challenges for humans working several hours inside a vehicle. In addition, Data management on the computer is in many cases time-consuming, as many work steps such as controlling the measurement, saving, file naming, and above all entering metadata are very time-consuming depending on the software's convenience, of course. If several different operators are working with the same laptop as part of a test campaign, clear processes must also be defined for standardizing data storage. And of course, manual data management is also prone to errors, especially if you have been sitting in the vehicle for a really long time. It is constantly hot or is constantly cold. If you lose your concentration or if the vehicle is constantly jerking, all of these are sources of typing errors and other inattentions. Well, let's see how our colleague, the data logger, performs here. The huge advantage of the data logger is that it generally works completely autonomously and therefore does not require technically skilled personnel to operate it at or in the vehicle. This, of course, saves time and personnel costs. In addition, the data logger is much less prone to errors. Firstly, because all the manual work on the site is not required, and secondly, because the hardware and software of data loggers are less complex, generally speaking. Our Unican 3, for example, is fully designed for reliability and stability. And a major key to this is its FPGA architecture. This means that we have developed our own CPU and own operating system for the Unican 3, allowing us to design all the parameters of the logger for almost 100% data security. Of course, we also have to configure the logger in advance. For example, we define the storage processes before, but we do this work before the test run so that the logger then automatically names all the files correctly, stores them in the correct location, and this even already during the measurement run. We therefore achieve an extremely high level of process reliability, primarily through the structured use of file names, especially the metadata, and the workflows do not change due to changing operators. So also here in step 2, the logger has many advantages over the computer. However, the logger has one major shortcoming compared to the measurement computer, and we don't want to withhold this from you. On the measurement computer, we can usually visualize the measurement data immediately and get first impressions of the measurement results straight away. Of course, we do not have this visualization with a logger that works in the glove compartment, for example. This means that in order to compensate for this advantage of the measurement computer, the data logger needs a way to give the user live access to the measurement data. And one such possibility is the so-called MQTT. MQTT stands for Message Queuing Telemetry Transport and refers to a standardized open transport protocol that originates from the IoT area, meaning the Internet of Things. And with an MQTT function in the data logger, we can now transfer information from the data logger or data loggers to a server in real time, virtually live, via a mobile phone or Wi-Fi connection. This can be system data such as GPS position or memory levels, but also measurement data from analog measurement modules or bus data from the test vehicle. And the data transmitted via MQTT can then be easily displayed in web-based dashboards, in other words, simply in the web browser of devices such as PCs, tablets, or smartphones. Well, in this way, it is even possible to maintain an overview of an entire test fleet at any time and from anywhere in the world just by using a dashboard if the test vehicles are equipped with connected data loggers with MQTT function. The huge advantage of this is that we can now immediately see whether there are any special incidents in all test vehicles simply on the basis of the live data in the dashboard. This also means that the person who previously had to sit on the vehicle with the laptop can now sit in an air-conditioned office with a good office chair, large monitor, access to good coffee and to the toilet. Sounds good, doesn't it? Well, how does MQTT work in principle? The clients, in this case, our data loggers, connect to an MQTT broker, meaning a server, and regularly store measured values there via a mobile data connection. On the user side, the measurement technician now also connects to the MQTT broker via a terminal device and subscribes to receive the data logger transmission. So some of you may be already familiar with this principle from your photovoltaic system at home. And now you may be wondering how the MQTT function is configured on a data logger. And that's very easy. And with our Unican Free, for example, it looks like this. We now simply create a so-called MQTT channel display group and can assign then many measured variables recorded by the data logger to this display group. And the logger then publishes this data via the MQTT protocol. It's simply as that. And this is what a dashboard could look like, for example, on which the data published by the data logger is then displayed. Among other things, we can now see here measurement data from strain gauges here on the left and down here, and some temperature sensors of an instrumented RC car that we use as a demonstrator at trade fairs. So let's summarize what the MQTT function in the data logger can do for us. We can transmit real-time information via a standardized transmission protocol and thus provide regular status information from the logger as well as live measurement data to a user who does not have to be on site. Data transmission is protected by authentication using a username and password, as well as message encryption using the TLS protocol. And in addition, the update rate can be set as required. And in the event of connection problems, the data is buffered by the logger so that no data is lost during transmission. Well, with the MQTT function, the data logger can therefore compensate for the display options on the measurement computer. Of course, not completely, but to the greatest possible extent. Now let's move on to step 3 in our test procedure, the data evaluation and analysis. And generally speaking, here the computer has an advantage over the data logger in this step, as we have good options on the computer with the corresponding software tools to go straight into analysis. However, there could be a problem here. For example, if data is accidentally deleted in the heat of the moment due to operating errors. What is the situation when using a data logger? Well, many data loggers today already offer the option of transmitting their measurement data via a wireless connection. Our Unican Free even offers two ways of doing so. Firstly, a downward compatible LTE modem and additionally a Wi-Fi module. And both modules are permanently integrated into this logger, so meaning that we do not need any bulky attachments on the logger apart from the corresponding antennas, of course. Now, what's really cool is that in the near future, the Unican Free will combine these two transmission paths even better, namely with the so-called ABC strategy. This will allow measurement data to be transmitted at the highest possible transmission speed, both during and after test drives. And this measurement data can then be used immediately for further evaluation, as it is already available in the standardized MF4 format. ABC strategy is an acronym meaning always best connection, and describes the ability of our data logger to have configured and offer several data transmission options at the same time and to automatically select and prioritize them depending on the best or fastest possible data connection. In other words, we have an LTE modem, we have a Wi-Fi module, and the logger always dynamically selects the best connection to transmit the measurement data. Another important function of the data logger for the rapid provision of measurement data is the just mentioned onboard data conversion of the raw data into a format that can be used immediately. With the Unican free, this means that the data logger itself converts the recorded raw signals internally into MF4 format, which can then be used immediately after readout or transmission, for example, for analysis. With the onboard data conversion function of the data logger, we compensate for the downside of delayed availability of the measurement data and are therefore on a par with the measuring computer here too. Let's move on to the last step in our test procedure, the adjustments or refinement of the measurement task that is often necessary after the evaluation. And one disadvantage of the computer here is that the adjustments or the refinements to the measurement task after the analysis are often very time consuming, in that sense that the test vehicle often has to come to the control center for modifying the test configuration. Well, good data loggers have an advantage here if they allow remote configuration. What does that mean? With the Unican Free, for example, we have the option of uploading the new logger configuration directly to the logger remotely via a mobile data connection if no adjustments needed to be made to the settings of the analog measurement modules. And in this way, the logger can be reconfigured directly, no matter where the vehicle is currently located, which on the one hand makes our workflow significantly faster and also saves personal costs when servicing the vehicle. Well, if we now think back of the four steps of our pre-series testing and the comparison of the measuring computer and the data logger in the individual steps of the showcased application, we can summarize our findings as an overview as follows. The use of data loggers, in particular the Unican Free with the functions presented, saves operating personnel, saves space in the test vehicle due to its small size, and increases occupant safety many times over. In addition, automated data management ensures a high level of process reliability in data storage. And data loss is virtually eliminated thanks to the secure remote transmission of measurement data. And with the MQTT connection, the ABC transmission strategy, and onboard data conversion functions, the data logger is also able to more than make up for its shortcomings compared to a measurement computer. And this means that the advantages of both worlds, those of the measurement computer and those of the data logger, are equally available to you in the form of an intelligent, compact data logger solution such as the Unican Free.